Hey guys, let's knock out this review for test 21. The first one says determine the leading term, leading coefficient, and the degree. The leading term, remember, is the one with the biggest exponent. So the leading term, LT, is, almost messed that one up, is negative 12x to the fifth. The leading coefficient would be the negative 12, and the degree is the biggest exponent, which is 5. Number 2, 3, 4, and 5 in behavior. Remember how we talked about these, like odd, even, odd, even, all the noises we made. Well, the first one, number 2, is odd and positive, which means it's going down to the left, up to the right. Number 3 is right there, even positive, is going up, left, up, right. Number 4, I have an odd negative, which means it's going up to the left, down to the right. And the last one here, number 5, is even and negative, which means it's going down to the left and down to the right. Number 6, use substitution, determine whether 2, 3, negative 1 are actual zeros. So what I'm going to do is I'm going to take the 2, I'm going to plug in the 2 and see what happens. I'm going to get 2 times 2 cubed minus 3 times 2 squared plus 2 plus 6. I'm going to do the same thing with the 3. This one's going to take just a second. 3 squared plus 3 plus 6. And then I'm going to do the same thing with the negative 1. So make sure when you plug that negative 1 in, especially you're using parentheses to plug that in, or even your calculator's going to give you the wrong answer. I'm going to plug those in real quick, see what we get. Okay, I plug those in. The values I got are right here, 12, 36, and 0, which means the only one that is a 0 would be negative 1 is a 0. Number 7, find the zeros of the polynomial and multiplicity of each. It's whatever the zeros, whatever makes the parentheses 0. So on number 7, negative 2 would have multiplicity 2. 3 is a 0. And also negative 4 would have multiplicity 3. Number 8, you got to factor first. I'm going to factor here. I'm going to go x squared minus 3 and x squared minus 1. X squared minus 1 can be broken down x plus 1, x minus 1. I'm going to go ahead and do difference of squares here, and I can do that as long as I put a square root, x plus square root of 3, x minus square root of 3. And here we go. The zeros are plus or minus square root of 3. All have multiplicity 1 because there's no exponents there, so just plus or minus square root of 3 and plus or minus 1. Number 9, use the graphing calculator to find the real zeros of this, approximate the zeros to 3 decimal places. This is where we graph it. We try to find the x-intercepts. We're using this second calc number 2 and going left bound, right bound. I'm going to go do that real quick, and I'll be right back with your zeros. Okay, guys, and here's what I'm getting. I got 3 decimal places, 2.545, also negative 4.378, and negative 1.167. Now, I'm going to be honest with you. I'm making this video at home. I forgot to bring home the TI-84, so I'm using an online calculator. So I'm hoping those are correct. If not, sorry, but they should be. Number 10, use the graphing calculator to estimate the real zeros, the max and the mins, and the range of that graph right there. Let me punch those in. Again, I don't have my calculator here. Let me see if I can find one real quick and give you those answers. All right, guys, punch that in on again, online calculator, which I'm hoping matches up perfectly with what you got. Did the same thing for the zeros I did in number 9. Second count, number 2, left bound, right bound, found both of those zeros, 2.86 and negative 1.75. Found the max, a second calc, I believe it's number 4 for max, and did left bound, right bound again, and found out it was like 3 halves or 1.5, or close, very close to 3 halves or 1.5. Matter of fact, I probably should put 1.5 there. And then the range, because that's the absolute max, it's not just a relative max, it's the absolute max, it's the top of the graph. And I know that because it's x to the 4th, which means both ends are going down. So the range is from negative infinity until 3 halves. Or really, I probably should put 1.5 there also. Hope that helps. Number 11, for this one, state the maximum number of zeros. State the number of x-intercepts, max number of x-intercepts, number of turning points the graphs can have. So this is just all, you don't have to worry about doing this exactly, just how many could it have. How many real zeros could it have? Whatever the degree is, 10. How many maximum number of x-intercepts? Guys, x-intercepts are zeros, 10. C, how many number of turning points could I have? 1 less than that always, 9. That's one of the easiest questions on the test. Make sure you got those patterns there. Number 12 and 13, graph these. 12, you got a factor first. Take out an x. That leave x squared minus 1. Keep going. be x plus 1, x minus 1. Now, when I started this one, it was x cubed, which means I'm going to go down, left, and up, right because it's odd and positive. This tells me where to put my x-intercepts. My x-intercepts are going to be at 0. It's going to be really close here. -1, I should have made this bigger. Matter of fact, I still will. -1 and +1. Those are my zeros. That's what's going to. Those are my x-intercepts. So my x-intercepts, I should write that there. X-intercepts are -1, 0, and +1. The y-intercept, to get the y-intercept, you put 0 in for the x, and what you get is 0. And obviously, if I put 0 for the x-intercept, it's also the y-intercept because it's on both axes. Now, because this was odd and positive, I know it's going down left, so it's going down left. It's going to go up through and back up that way. And that's all you need to do for that graph. Just a general picture of what the graph looks like. Number 13 is already factored for you. So let's go here. X-intercepts, or whatever makes these, are also zeros. So I got a 0, a 1, a -3, and a -5. And that comes directly from those. So I'm going to put a point at 0, at 1, at -3, and -5. Now, because there's 4 x's, there's really x to the 4th, which is even, and there's positive in the front. So both ends are going to go up. And then we got to go through those points. Now, the y-intercept, again, you put zeros in for the x's, so it'd be 0 times -1 times -3 times -5. So that should be a +1. But that's all going to be 0 because there's 0 in the front. So the y-intercept is also 0. Anytime the x-intercept 0, so is the y. Now, because it's x to the 4th, it's even positive. It's going up left and up right. So it's going to look something like that. I'm not worried about how exact it looks. I'm worried about that you cross the x-axis at the right spots and also that your ends are going the right way. 14, use the intermittent value theorem to figure out if there's a real 0 between 1 and 2. All right, so what I'm going to do first, I'm going to plug a 1 in there. I'm going to basically do f of 1. I'm plugging 1 in. 3 times 1 squared minus 9 times 1 minus 13. Also going to plug in 2, just like we did a few minutes ago. 2 cubed plus 3 times 2 squared minus 9 times 2 minus 13. I'm going to take a second, plug both those in. All right, I plugged those in real quick. I'd be honest, I did it in my head, so I'm hoping here. I got -18 when I plugged in 1. When I plugged in 2, and you can see the numbers I got down here on the bottom. I got -1 when I added those. No, I don't. I should get -11. Sorry about that. -11. So I just caught my mistake just talking to you. But anyway, because they're both negative, that means the graph did not cross the x-axis between 1 and 2, so there's no zeros there. So does it have a 0 between 1 and 2? The answer is no. It'd be yes if I got different signs on those. That's how you can tell if you got different signs. Number 15, less than. All right, a little blast from the past here. So I'm going less than 12, greater than -12. Add 7 to all 3 sides. I get x's, I got 13 over there. Got -5 over here. You can do a number line if you want to. -5 and 13. Fill it in circles. And then your interval notation, 5 to 13. Number 16, got to multiply by the conjugate here. The conjugate of 5 minus 9i. Obviously 5 plus 9i. Y'all know that by now. When you multiply conjugates, remember doing food. So I'm going to do first times first, 5 times 5. Last times last, 81i squared. The I squared makes that a -81 become +81. 25 and 81 is 106. Then distribute. 2 times 5 is 10. 2 times 9 is 18i. Now, because they're all even, go divide everything by 2. Make that 5 plus 9i over 53. And there you have it for 16. Got one more. 17, complete the square, your favorite thing. All right, so start off by, if you want me to quit putting these on there, I'm just asking, just get it right, just do it. All right, so once you start getting them right, I'll quit putting them on there. So half of -6 is -3, square it, plus 9 on both sides. It gives me -4 over here. Over here I can factor now. What factors of 9 give you -6? What 3 and 3 do? Also, don't forget, whatever that half is up there always goes inside. Take the square root of both sides. I'm going to get plus or minus 2i over here. Square root of -4 is 2i. And move the 3 over and you're done. You get 3 plus or minus 2i. And there you have it. Hope that helps. See you tomorrow when you come take this test and make like a, I don't know, 100 or something. All right, so see you then.